Okay, introduction to differentiation. Well, we're just going to start by looking at a linear graph. In front of you, you'll see the graph y equals 2x plus 1. Now, first of all, we need to know how to work out the gradient of this line. Now, the gradient of this line you can get by doing y2 minus y1 over x2 minus x1. And if you choose 2 points, you could work that out. 0, 1 and 1, 3. You could work it out and you'd get the gradient of 2. Now, the gradient of this line is constant throughout. The gradient here would be 2, the gradient here would be 2, the gradient here would be 2. Okay. Now, what we're going to do is we're going to now look at a quadratic graph, y equals x squared. Now, here's that graph. Now, if I was to look at the gradient of the tangents of this graph, so if I look at the tangent at that point, now remember a tangent is a line that just touches the curve and carries on in the same direction at that point, so it would have the same gradient. So if I looked at the gradient at that point, and the gradient at that point, and the gradient at this point of the tangent, and the gradient at this point of the tangent, and the gradient at this point of the tangent, it's going to change throughout. So it's not as simple as in the last case where you just work out the gradient, it would be the same throughout. So if I wanted to work out the gradient at different points, well, what I'd have to do is I would have to differentiate the equation of the graph. Now, what we're going to do is we're going to start by looking at a point where we know the gradient. A point where we know the gradient of the tangent is here at x equals 0. At x equals 0, the tangent obviously is horizontal, the x-axis, and the gradient will be 0. Okay, now what I want to do is consider the points 0, 0, 1, 1, 2, 4, and 3, 9. What I want you to do is I want you to work out the gradient of the chord from 3, 9 to 0, 0, from 2, 4 to 0, 0, and from 1, 1 to 0, 0. So I want you to work out the gradient of those chords. Okay, you've done that, and you've worked out the gradient of this chord is 3, the gradient of this chord is 2, and the gradient of this chord is 1. Now we know the gradient of the tangent at this point is 0. Now as you notice, as this point gets closer and closer to x equals 0, the gradients of the chords get closer and closer to the gradient of the tangent at that point, which is 0. It goes 3, 2, 1. Now if I consider the chord from maybe perhaps this point, the gradient of the chord would be less than 1, it would be a decimal, and as it gets closer and closer, it would approach 0. Now this is really important. What it means is, it means that we can actually consider a point, any point on the graph, consider a point just beside it, and then we can work out the gradient of that tangent at that point by working out the gradient of the chord between the point and the point just beside it. Just like here. Okay, let's consider this point. So we've got this point here, which is on the graph. So we're going to call it x, obviously x across. Now the graph is y equals x squared. So it's not, we're not going to call it xy, we're going to call it x and then x squared because y is x squared. So this point here is x squared. And the point just to the right of it, here, is going to be, well, we're going to move across a tiny amount. Well, let's move across h, okay? We'll let h be a tiny number. So the x coordinate of that point would be x plus h, x plus that tiny number. And the y value at that coordinate would be x plus h squared. Okay? Now if I want to work out the gradient of that chord between x squared and x plus h squared, what I would do is I would use the equation y2 minus y1 over x2 minus x1. Now by doing that, you would get, well, first of all, x plus h squared minus x squared, y2 minus y1, all divided by x plus h minus x, which is your x2 minus your x1. Expanding these brackets, you would get x squared plus 2hx plus h squared minus your x squared, all divided by, well, your x take away x cancel out, so you're just sort of left with h on the bottom line. Now, what you're going to do is you're going to simplify the top line by doing x squared take away x squared. They're going to cancel out, so you're going to be left with 2hx plus h squared, all divided by h. Now you're going to divide through by h here, you're going to get 2x plus h. Now remember, h is a tiny number, so the differential of this would be 2x. So the gradient of that point, the gradient there, would be 2x. Now that's really important because x is any coordinate that we want on the graph. So to work out the gradient at any point of the tangent, at any point in this quadratic graph, y equals x squared, all you do is you take the x value and you multiply it by 2, because it's 2. Okay, so congratulations, you've done your first ever differentiation. You've gone from your equation of the curve, y equals x squared, you've differentiated that, and you found the derivative, 2x. Now what I want you to do is, and I want you to do exactly the same for y equals x cubed. I want you then to find the derivative. I then want you to do the same for y equals x to the power 4, and I want you to find the derivative. And then what I want you to do is, I want you then to see if you can spot a pattern from how you go from the equation of the curve to the derivative. Okay, and if you can do that, that would be fantastic. Now, if you want any extra help, feel free to come and see me, and well done.